Alright, I'm going to show that the derivative of natural log of x is 1 over x. So I'm basically going to show the proof that if f of x is equal to natural log of x, then f prime of x is equal to 1 over x. Proof is done with a very simple way, that is to use the first principle formula of the derivative, which says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now that we have f of x here, just put it aside. Is natural log of x. It also means f of x plus h is equal to natural log of x plus h. So we are going to substitute this into the formula. So we are going to have the limit as h approaches 0 of f of x plus h, which is just natural log of x plus h minus natural log of x over h. This takes us to, we can simplify that by capitalizing on the log law that says log of a minus log of b, natural log of b actually is still a over b. So as a result of that, I'm going to have the limit as h approaches 0 of natural log of x plus h divided by x, all divided by h. If I put the h here, this is going to look like this. Limit as h approaches 0 of 1 over h natural log. Then I'm going to simplify what's inside the bracket by simply distributing the denominator. It becomes 1 plus h over x. Alright. So we further manipulate this to complete the proof. We need to remember that, natural log is an inverse function of the exponent. So e can be approximated. Let me just write it properly. This should be limit. The limit as h approaches 0 of 1 plus h over 1 over h. This is probably justified by just looking at the graph of e, which looks like this. So it's passing through 1 here. So if we want to look at this is x and this is y. If you want to look at the limit of e as x is approaching 0 from the left hand side, it goes straight to 1, which is the same as the limit as x is approaching 0 from the right hand side, so it's 1. So it justifies that. So this also tells us that we can remove the exponent on the right hand side and put it on the left. It becomes e to the power of h is approximately equal to the limit as h approaches 0 of 1 plus h. Now if you carefully look into what is in our expression here, we do not have that. We do not have h, we have h over x in this expression here. We have h over x. So we can further manipulate that as well to say the limit of h approximately equal to the e of h is approximately equal to h over 0, 1 plus h. If I say over x here, this also becomes over x. So that's equivalence. That's just basic manipulation. So we are going to, but before I substitute, let me just say this is equivalent to 1 over h natural log of the limit h over 0, h approaches to 0 is of 1 plus h over x. When we just swap this, that's entirely okay. Now, this leads us to 1 over h natural log of this whole value here is equivalent to just e to the power of x, h over x. Again, we are aware that the natural log of a number, of an exponent, since these two are going to be, this can be written as p natural log of m. So we are going to use that as well here and say this is equal to 1 over h, the natural log of this value here. Actually, I should write it, sorry. This goes there, it becomes h over x, the natural log of e to the power of 1. And we actually know as well that these are inverse functions, so the natural log times e just simply reduces to 1. So we are left with 1 over h times h over x, which equates to 1 over x. Proved. Thank you for watching my video.